Ladies and gentlemen, may I have your attention, please? Ladies and gentlemen, may I have your attention, please? For those of you in the back, may I ask you to take a seat with us, please? For those who have met me, you'll know I live for these STEM events, STEM camp, STEM conference. This is what keeps me going. This is where I get my energy to go through the academic year. The Friday is always my very favorite day because we get to see young persons in the Cayman Islands at their best. We get to talk with them at the Ambassador Breakfast, and we get this very special session. For the last few years, every Friday morning at the STEM conference, we invite the Rotary Science Fair winners in each category to present their project. So we can see what research is happening in the Cayman Islands, we can see what the young persons in the Cayman Islands are doing, and we can learn from them. It is my absolute pleasure this morning to introduce our first presenter. Are we ready? No, we're not ready? Okay. Are we ready? All right. I'm going to do some housekeeping. For those of you who are not UCCI members, just cover your ears. DE students, can you please remove the headphones and the earphones and put the phones down for me, please? We are going to give our undivided attention to the speaker. And I still see some cell phones. I might have to ask Dr. Erica to walk around and confiscate them. And then I can make lots of phone calls later. All right, here we go. From Lehman Scott High School, having flown over from Cayman Brac since Wednesday morning, we have, presenting on saving our waters with plants, Siri Bata.
Good morning, everyone. I am so honored to be here this morning. As you can see, my name is Siri Chantanabata, but just Siri is fine. Today, I will be giving a presentation in relation to my research and findings on a science fair project that I had performed in the past. And the title for that project was Saving Our Waters with Plants. So a quick introduction to me. I am 15 years old. As Ms. Gale said, I attend Lehman E. Scott Senior High School, abbreviated to LSHS, in Cayman Brac. I placed first for chemistry for my school's annual science fair and placed second for the chemistry division in the Dr. Bill Hrudy Science Fair competition that was hosted by Rotary Club. Every science fair project starts from and revolves around a question. My question was, could polysaccharide extracts found in foods be used to attract microplastics in the ocean? All right, before I can dive into my hypothesis and findings and such, I should explain the reasoning behind conducting this investigation. Let me begin with, what are polysaccharides? Polysaccharides are carbohydrates, such as starch, cellulose, or glycogen, whose molecules consist of a number of sugar molecules that are bonded together. Here's a diagram to better understand what a polysaccharide is. In this example, we have starch. We can see that this starch is composed of glucose molecules, which are also commonly referred to as sugar molecules. Now, what are microplastics? In the ocean, there are millions of microplastics, which are little pieces of plastic that are 5 millimeters or less in length. And it is suggested that we unintentionally consume tens of thousands of them every year. So why did I carry out this investigation? What is the problem? Well, in the typical wastewater treatment process, microplastics are removed from water by adding flocculants, or sticky chemicals, that attract microplastics and form large clumps. Those clumps then sink to the bottom of the water and can be separated from it. The issue with that is that some of these substances currently used to remove contaminants are potentially harmful, hence why I decided to investigate non-toxic alternatives like polysaccharide extracts found in food. For example, one common flocculant, polyacrylamide can break down into toxic chemicals under certain conditions, which is definitely counterintuitive. Dr. Rajani Srinivasan at Tarleton State University in Texas suggested that polysaccharides could be used to attract and capture pollutants such as dyes or even bacteria, because the biopolymers, which are synthetic substances comprised of macromolecules, within them possess the appropriate chemical and biological properties to do so. All of this was stated in an article on the American Chemical Society website. I will state my references later in this presentation. Okay, so my hypothesis was, due to its properties, the polysaccharide extracts found in various foods would be able to attract and capture microplastics. I think that okra would attract more microplastics, as its polysaccharide content is higher than that of fenugreek. What I mean by this is that I expected my experiment to work in the first place, and for okra to be the more effective solution. In my investigation, I was comparing the effects of okra and fenugreek extract. So my aim for this experiment was to prove whether polysaccharide extracts found in various foods are able to attract and capture microplastics or not. And an additional aim that I had was to compare the abilities of okra and fenugreek to see which one was better. So these are my variables. My independent variable, or what I was changing, was the type of polysaccharide extract, okra or fenugreek. My dependent variable, or what I was measuring to get my results, were the amount of microplastics left in the water. And my control variables, or what factors I considered to keep the experiment fair and reliable, were the mass of polysaccharide extract being added, the volume of water in the bowl, and the mass of microplastics added into the water. I won't go over my entire specific process, so I will present a simple overview of how I performed this experiment. So I filled 2 bowls with water and added the same mass of microplastics to each one. Then I added okra and fenugreek extract to each bowl respectively. I left the bowls for a few nights so that they had enough time to produce acknowledgeable results. Then I skimmed off the polysaccharide extract from the top and measured the mass of microplastics left in the water. Finally, of course, I repeated the experiment 3 times to ensure accuracy and reliability. Here is my results table for my specific experiment. For reference, I added 5 grams of microplastics to each bowl of water. And as we can see, that was reduced to 0.28 and 0.42 average respectively. That means that the polysaccharide extract in general was very effective. And we can also see that okra has a lower average mass of microplastics left in the water, meaning that it worked better. So, in conclusion, my hypothesis was proven correct. The amount of microplastics remaining in the tap water decreased significantly, with okra having less than the fenugreek, meaning that it worked better. So this is just a representational graph for the average values shown in my previous slide. Like I said, okra was 0.28 and fenugreek was 0.42. So for my analysis of this experiment, as we can see, the polysaccharide extract from the okra worked better than the fenugreek, although both of them were quite effective. And that is because the biopolymers possess the biological and chemical properties to attract and capture the chemicals which make up the microplastics. And I mentioned this fact in my previous background research. Like I said earlier, I made references to the American Chemistry Society, and these are the websites or organizations from which I got the majority of my research and ideas from. So as you can see, I got my advice from an article by the American Chemistry Society and one from phys.org. Okay.
Thank you very much, Siri. I think she deserves a slightly louder. There we go. So we'd like to invite any questions from the audience. We do have other microphones that we can move around the room. So if you raise your hand.
Hi. How did you measure the amount of microplastics in the water?
Okay, that's a good question. So what I did was I drained and dried the microplastics so there wouldn't be any excess water left, and I used a top pan balance to measure the mass of how much was left. Okay.
There are many diverse polysaccharides, so why were those the two that you chose to use to test this experiment?
So like I mentioned in the article, the American Chemistry Society investigated okra and aloe, and fenugreek was one that I decided to investigate myself, but I wanted to use okra because it was shown in the findings that that did work.
Thank you very much, Siri. Can we get another round of applause, please, for our young scientists? Our next presenter is from the Footsteps School. Having won the prize for the Food and Health section of the Rotary Science Fair competition with a title, CO2 Much. I liked this one. I teach chemistry, for those of you who don't know. Tom Osborne. Ladies and gentlemen, can we get a round of applause for Tom, please?
Nobody else.
So we're press this, it'll go to the next slide. Okay. Hi, my name is Tom Osborne, and this is CO2 Much, an investigation into air quality and health with solutions. A global pandemic finally taught us the importance of clean air. Scientists now know many viral illnesses are airborne. They are transmitted by breath. Microdroplet viral particles float around as aerosols in the air. In 2020, aerosol scientists tried to warn the World Health Organization that COVID is airborne. It took a long time for doctors to accept what physicists and engineers were telling them. Virus particles are exhaled. They float, linger, and move like smoke. They build up in poorly ventilated spaces. Doctors can't treat infected air, but engineers can. Doctors first said viruses only spread via droplets, so they recommended washing hands. Once you accept that COVID and other viruses float as airborne aerosols, you can start to fix the problem. It's actually easy to improve indoor air quality. You can ventilate by opening windows and doors. You can filter indoor air and trap virus aerosols, plus smoke, dust, and pollutants by using HEPA filters. CO2 levels are a proxy for air quality. People exhale CO2. You can take CO2 readings to know how stuffy the air is. The stuffier the air, the higher the health risk. I used an AirNet 4 air monitor to take readings all over Grand Cayman. How to tell if the air is bad? We measured the CO2 parts per million. These are examples of my CO2 readings. I graphed the CO2 levels using an iPhone AirNet app, then logged in the highest readings at each location. These are the results of my CO2 readings in public spaces, in stores, banks, offices, pharmacies, coffee shops, the theater, and my own school classrooms. Classrooms have the worst air quality. The best air quality is in large, airy, uncrowded spaces with high ceilings, like hardware stores. The poorest air quality is in small, low-ceiling, crowded rooms. Classroom air is the worst. Clean air is as important as clean water. Just like fish tanks need water changes and filters to keep the water clean, students also need fresh air and filtered air for a healthy classroom. Ventilation is easy. Periodically open windows and doors. But how can you clean the inside air? With these. This powerful machine sucks air through 4 filters and blows out clean air. And kids can make one in 45 minutes. They are Corsi Rosenthal boxes. Corsi Rosenthal boxes are powerful, homemade air cleaners invented by Dr. Richard Corsi, the Dean of Engineering at California, and Jim Rosenthal, the Tex Air CEO. The boxes trap virus particles, dust, and pollutants. They're as effective as $1,000 HEPA machines, but cost $85 to make. I spoke to my local media to inform my community. I showed Sunrise Adult Training Center how to build Corsi Rosenthal boxes, and I hope more people will build them. 250,000 Corsi Rosenthal boxes have been built worldwide by citizen scientists to remove airborne viruses, forest fire smoke, and air pollution. New Scientist has just published research showing air filters cut sick days in schools. Dozens of peer-reviewed studies have already shown that air filters work on viruses and pollution. Now a randomized controlled trial shows sickness absences were significantly reduced by cleaning the air. Clean air is just as important as clean water. All of us deserve to breathe clean air.
Absolutely amazing. Thank you so much. One more round of applause. Yes. Do we have any questions for Mr. Osborne? Any questions from the audience?
Hello. Is it possible that you can show us how it works?
Yes. So the way it works is air goes through these filters, and then this fan views clean air from the top. Okay. So these air filters, bad air comes through them, and clean air comes out the top. And these filters, they don't work like strainers. They work more like spider webs.
Thank you. All right, ladies.
Can you please turn it on?
Do we have any other power outlets down here? I don't want to unplug anything and then you guys tell me I broke the mic. In the meantime, let's take these other questions.
So how would you possibly clean it?
So you would need to change the filters once a year. But it was actually shown that one of them was left unchanged for 8 months and the filters turned gray. And surprisingly, it actually worked better than one with brand new filters.
Okay.
Out of the millions of science experiments, why did you choose this one?
Well, to the COVID-19 pandemic, plus we do need clean air.
Yes, we do. Thank you so much. Another round of applause for Mr. Osborne.
Okay.
Ladies and gentlemen, we have another amazing presentation for you. I'm going to ask you to give your undivided attention to the winners of the Life Science category at the Rotary Science Fair 2023 with their topic, Can You Retrain Your Brain? Homeschool students Ashley and Brandon Spencer.
Our question is, can you retrain your brain to read upside down? I'm Ashley and I'm Brandon. Our research, a year and a half ago, I was diagnosed with dyslexia. My mom bought a book called Overcoming Dyslexia. When she was reading in the book, she heard about neuroplasticity. Neuroplasticity is how the brain can adapt and change based on experience. People always say practice makes perfect. Well, I'm going to say a little bit about why it actually does. In your brain, when you're doing messages, the messages go through, pretty much like tubes into your brain. The messages go through, and it shows your brain. But the more they go through, this thing called the myelin sheath wraps around them, which makes them 1,000 times more faster and more efficient. I could probably talk about this for hours, but I know we don't have a lot of time, so we better move on. Did you know that brain cells are always changing their connections? It doesn't mean that the existing connections stop working, but it means that you can learn new things at different times. There's a bunch of new things you can learn, and even adults are always changing their connections in their brain. Our hypothesis is, if someone were to start reading upside down every day, that they would get faster, faster, and faster. The things we used were, we used 2 grade 5 level reading sheets. We made sure that they were the same ability. For our first test, we used this one called the best vacation ever. For our second test, we used this one called jump around. We also used a really special chart that helped record our results. We recorded how many they got right and wrong. We also had a 1-minute timer and a pencil. The procedure we did was, first we would time them for a minute reading upside down on the first sheet, the best vacation ever. I would count their correct words and their incorrect words, and Brandon would write them all down on a special chart. We told them that they needed to practice reading upside down for the next week, because it's really important to practice so that those connections get thicker. Then we brought them back the next week and asked them how many days they had practiced, for how long, and then we did the same thing over again with the different reading sheet called Jump Around. Brandon recorded their results, and I counted their correct words and incorrect words. And then we put them together on a chart. This is our data.
You're probably you can see that we split it into 3 different charts: kids, teachers, and adults. The light pink is the first time that we tested them, and the dark pink is the second time. You can see that everyone improved.
We were originally going to separate it into 2 different categories, kids and adults. But we noticed that 4 of our adults were going a lot higher than anyone else. So we looked into it farther, and we found what those 4 adults had in common. They were all teachers. This makes sense if you think about it, because teachers are used to working in an environment where they're constantly reading upside down on kids' desks. This is our kids' reading results. We noticed that age didn't make a difference. We had from ages 11 to 17. Some of the older kids got lower than the younger kids, and some of the younger kids got lower than the older kids. It was just a big mix. You can see in this chart that the people who practiced more days improved more than the people who practiced less days. Like this person practiced 5 days, and the other person only practiced 3. Now the person who practiced 5 days improved a whole lot more than the person who practiced 3. These are our teacher reading results. They all did really, really well. And these are our adults. They didn't actually do a lot better than our kids, so we found that kind of strange. Our analysis is that every single test subject improved. Age did not make a difference. Teachers scored higher because they've practiced reading upside down pretty much every day of their life when they're on their jobs. And we noticed that the people who read less words on their first try were able to increase a lot more than the people who read people who read more words on their first try. And the people who practiced less days didn't improve nearly as much as the others.
Our conclusion is that yes, you can retrain your brain to read upside down.
So practice actually does make perfect, or it makes better than, it makes you improve and better. This shows that people can learn new things and make new connections in their brain at all ages. Because cells that fire together, wire together.
That was awesome. Don't you agree with me, ladies and gentlemen? Wasn't that an amazing presentation? We're going to take a few minutes to invite any questions from the audience. You can raise your hand and we'll bring the microphone to you. Any questions from the audience?
Ashley, did you or Brandon try it yourselves and see any improvements, or was it just other people?
I did try it myself. Since Brandon has dyslexia, it would be hard to compare him with all the other kids, and he also wasn't above grade 5 level readings, so we couldn't quite. But I did try it myself, and I was actually one of those test results.
All right. Any other questions from the audience? I see a hand? Okay. And you race across the room with my little short legs. Whose hand was up?
Why did you choose this topic?
Well, I think Brandon can answer this one.
We chose this topic Because since I had dyslexia, we wanted to choose something that involved dyslexia. So this was the best thing that we could think of.
And also, people with dyslexia usually have a special tutor that helps them. And people who know a lot about dyslexia tell them that they can retrain their brain to learn how to read, because with dyslexia, they just have a few parts in their brain that aren't activated, so they have to practice really hard to activate those parts in your brain. So we thought that if someone with dyslexia can retrain their brain to do something like that, other people can easily retrain their brain to read upside down.
Thank you. Any other final questions from the audience? Ladies and gentlemen, can we have another round of applause for Ashley and Brenda? Ladies and gentlemen, I noticed some persons walked in at the perfect time. Get to see all of these amazing presentations. Some of you missed the breakfast. The breakfast was really good, wasn't it? No, it wasn't? No? Okay, so we're going to fill out those evaluation forms later. Kes, hide the evaluation forms. We ready? Ladies and gentlemen, the physics category presenting on coconut husks. I'm going to let him tell you the title because he thinks it's clear that they won't disappear. Coming from John Gray High School, our neighbors are right across the road, Mr. Christopher Saraton.
I would just like to say that this mostly has to do within the chemistry. It's physics, chemistry, and computer science. But I still don't know how I can go up after those two. So, hello, my name is Christopher Siratin, and I am the winner of the Rotary Science Fair for Physics, Chemistry, and Computer Science, and my project was about coconut clarity. Now, when I was researching this topic, I originally did it in John Gray, and I was looking for ways that you can filtrate water. And I came across coconuts. They're renewable, and I found how husks, people never use husks. It's outdated. Now that string is available, and so much more. And after seeing this, I decided that I wanted to research and found that coconut husks are very crucial when filtering water. So just before I go into this, I just like to do a bit of background research. So in things like construction and agriculture, they're impoverished countries. They don't have the clean water to do all sorts of things. And there's new nanoparticles and more chemicals that can pollute these waters. I wanted to find a way that can try solving this. So, and just before I go into my question and hypothesis, I want to say water filtration has been very long ago, 500 BC, with the Hippocrates sleeve. What it did, it was just like a piece of filter paper. And that evolved all the way to the 17th century with Robert Thom's filter with wool, sponge, and carbon filters. It's the foundation we build today for things in sinks, bathtubs, and even in our fridges. So my question for this experiment was, can coconut husks improve the effects of water filtration when used in combination with traditional methods of filtration? I wanted to find this out for myself, and I wanted to see if I can expand on the filtration with coconuts. And my hypothesis was coconuts can improve the effects of water filtration by a substantial amount. Now, why did I choose coconuts? Well, they have sustainability, porosity, and water retention. For sustainability, it's reusable, biodegradable, and it's being repurposed. For its porosity, not only are they durable, they have micropores that can trap this wastewater, and macropores which exchange it for gas and water, this gas being carbon dioxide. And finally, for its water retention, it has these fibers called parenchyma found in a lot of plants, but for coconuts, it has a high retention and absorption. Now, these are the materials if you wanted to see for yourself. And now finally, I have the method. That's a diagram if you just wanted to see what it looks like. But to put it into perspective, I crush coconuts into powder and cut a coconut in half to extract the husks. Then I started building the experiment where I used a bottle right here. I cut the bottom off and I put cotton balls at the bottom to prevent any of the water seeping. Then I used a mix of charcoal and sand in layers respectively. And in one of the bottles, I put coconut husks. The reason I use charcoal and sand, it's extremely popular as a filtration device for homemade people, and how it can be used DIY and all sorts of things. And once you get your dirty water, which is a mix of dirt, water, and other sorts of things that can pollute it, you can put it in each bottle, and you can, it's like it drips down into the cup below, as you can see. And once it does that, you can just observe from there. Now, before I do this, I need to mention the variables used. Now, I have my independent variable, which is what I'm changing. So the filter materials. I use sand and charcoal evenly, but for one filtration method, I use coconut husks. The dependent variables, the things I want to measure. So I'm measuring the pH and the clarity of the water. For the pH, I used a universal indicator, and for the clarity, because I didn't have any of the scientific equipment, I can only use light to see if it was translucent or not. And for the controlled variables, the things I'd be keeping the same. You can see the sand and charcoal, the measuring tools, the shape and size of the bottle, and so on. Now, finally, for my results. For the clarity, or as I'm going to refer to it now, turbidity, we can tell the dirty water, it's translucent, but you can't even see it. For the two filtrates, if you can see the coconut, it is discolored. That is one of the limitations I had, as the husks I used were old. If I were to use younger husks, it would have a much better effect. But for these two, you can tell that the filtered water without the coconuts, you can tell how it is a bit more translucent, while the one with the coconut husks is more transparent than the other one. And you can see, like, from the top, you can't even see from the bottom, but for the coconut husks, you can. And for the pH, I measured each. So before the filtration, you can see the pH scale. And if for reference, this is the pH scale at the bottom. For the one without any husks, it always ended up at 5, but for the one with the husks, it always ended up closer to 7. Now for my analysis, I saw that coconut husks paired with charcoal and sand did improve the water clarity and pH levels, which showed an improvement in the water quality, and how the pH was closer to 7. Now, as I said before, some of the limitations I used a universal indicator when I could have used more sensitive equipment, and how I only used sight to measure the turbidity when I could have used a turbidimeter, which is more reliable. And as I said before, the discoloration made by the coconut husks, that's also a problem because it could affect the use of sight, as if I had a turbidimeter, I could have used it more effectively and it would have been more reliable. Now, for my conclusion, coconut husks are found to increase the water quality, not by a substantial amount, but a slight amount that it can be used, and how if you just build up on this more and more, you can increase the potential. And if I wanted to go beyond and just find out what I could have done different and what I could have done to extend this project, I could have tested different types of water. So I could have used rainwater, seawater, and I could have seen the benefits of it. I could have seen the placement, because I put it at the top, but that's not fully going into the experiment of using coconuts. I could have put it on the bottom, put it on the top. I could have used more surface area. And I could have, instead of using charcoal and sand, I could have used more filtration methods in order to fully see how coconut husk can be used. And that's it.
Thank you very much, Christopher. That was really, really good. That's rather enlightening. Do we have any questions from the audience? Can we get another mic on that side of the room? Dr. Young, can you help me, please? Can we get another mic on that side of the room to Dr. Young, please? Let's start with the question over here in the meantime.
Yes. So, can you tell me why you did not use other things like younger husk or different water?
It was more as so the ability to get these resources as younger coconuts are, well, the time I had to do this experiment, it was a bit of a limitation as I couldn't have gotten these younger coconuts as like, I didn't have any devices to determine if these coconuts were young or anything like that.
Did you look into to what level this can be extended? What I mean by that is this for personal use? Is it efficient enough for a household use? Or can it be used for a whole community? At what point does it not make sense versus other alternatives? And where is it economically feasible and productively feasible? Into how fast can you keep producing clean water?
Now, originally, I saw this company called EcoFlow, I was originally planning on doing an experiment like that, but it requires a lot of money, as you would have to char and freeze dry specific coconut fragments, and it actually has a really good filtration method. It removes all the microplastics and all nanoparticles. It's a really good way, and it can be mass-produced, but what I'm doing, I think it could just be used for homemade, if you want to just get some clean water, like if you have a small agriculture farm, or if you want to mass produce this to do stuff in construction, it's very useful for that.
Thank you, Christopher. Any other questions from the audience? Can we get another round of applause for Christopher Siratin? While we get the final presentation set up, we have one more presenter. Mariella Wright from Cayman Brac Creek Primary won the prize for the Young Achiever Award with her presentation, Moldy Moldy. Mariella could not be here with us this morning, but she sent a very, very short message, and she wanted to share some photos of her presentation. So we're going to get that set up right now, just a few more minutes. Not a few more minutes for the setup, a few more minutes for the rest of the session. All right, here we go, ladies and gentlemen. Your message from Mariella Wright. Moldy Moldy is her topic from Creek primary, she won the Young Achiever Award in the Rotary Science Fair 2023. All right, I'm not sure why that's not playing properly. Mariella was very shy, and she did not want to give a long presentation. She just wanted to introduce herself. It says, "Morning, my name is Mariella Wright, and I won a prize at the science fair." Mariella also wanted me to share 2 photos with you, so we're just going to put those photos up now. That's Mariella with her certificate and her presentation. That's Mariella next to her presentation. Mariella's presentation was on preventing mold in bread. She said she actually had a lot of fun putting the presentation together and just seeing how the bread changed over time. Can you see her poster? She just looks so cute. She really had a good time putting the presentation together. She said she did enjoy working with the project and doing the science fair presentation. But as I indicated before, she was very shy. She didn't want to join a Zoom call this morning, and she didn't want to send a long presentation, but she still wanted you to see what she did and to see that smile. Look at that smile. She really enjoyed herself. Thank you very much, Luis. Ladies and gentlemen. Yes. Thank you. I would like to thank you for your attention this morning. I just want to say, did you hear the eloquence? Did you see the quality of those presentations? Ladies and gentlemen, that's the next generation in the Cayman Islands. Those are the next scientists. Those are the next engineers. I'm really looking forward to seeing what our society is going to look like in the next 10 or so years when they take over. We have some educators in the room this morning. I'm going to ask all of our educators to stand, no matter what capacity, whether you're homeschooling your own children, you're a lecturer here at UCCI, you're an assistant professor, full professor, teacher, principal. I'm going to ask all of our educators to stand, please. Thank you for all of your work. Thank you for all that you're doing. I know it's not easy. I know it's one of the hardest jobs, and you put so much into it and so much into the young people here in the Cayman Islands and wherever you are from. Thank you. Can we get another round of applause for our Rotary Science Fair presenters, please? Presenters, continue to be hungry. Continue to look for answers. Continue to do your research. Continue to ask questions and try to answer those questions. For those of you who have not yet taken on that journey of asking your own questions, whether in STEM or in other areas, use this as an inspiration. You see what the smallest of us can do. Look at our tiny little pebble in the middle of the Caribbean Sea. Do you realize how much power we have? Do you realize what we can really do when we set our mind to it? You see the Cayman Islands flag everywhere. Let us continue to hold that flag high. Let us continue to do the work that we are doing, and let us continue to grow this island. We can't make it any bigger as an island, but we can make it bigger as a people. Thank you so much for your attention. We're going to take a short break, and Aditi Joshi will be here at 10:30 for the presentation on artificial intelligence. Thank you, ladies and gentlemen. coffee here. Well, I'm sorry, the coffee moves to the. I think the speaker will probably come.
Great, thank you.